Now we are going to discuss basic algebraic properties of complex number under addition. First we will discuss properties of complex number under addition, then under multiplication. Here we will see how can addition affect commutative property, associative property, or how does existence of additive element is possible and how does inverse exist. So the first property is under addition operation is that is closure property. The closure property. The first property is that is the sum of two complex numbers is also a complex number. That is, in mathematical form, if Z1 and Z2 be two complex numbers, then their sum, that is Z1 plus Z2, must be belongs to complex number. That is, addition is closed under closure property and addition is a binary operation on complex number. What is binary operation? If we have two elements of a set and their addition or product belongs to again that element, that is there is no effect in the form, that is called binary operation on real number, complex number or integer or something, some other number. So second property is that is commutative property or commutative law. What does this property mean? It means if we add two numbers in a order first and second and then again take the product or addition in reverse order, then their answer or result remains same and belong to same number system, then that is called commutative property. That is, if Z1 plus Z2 is equal to Z2 plus Z1 for all Z1, Z2 belong to C hold, that is commutative law hold. In complex number. Now the third property is the associative property. In this, if Z1 plus sum of Z2 plus Z3 is equal to sum of Z1 plus Z2, then adding Z3 is come out to be same, then it is called associative property is fulfilled. For all Z1, Z2, Z3 belongs to complex number, then associative law hold. Now the next one is fourth property, that is existence of identity element. That is, what is meant by identity element? That element which when added to the given number does not alter the number, that is called identity element. So in complex number, there exists a complex number zero, that is whose first element is 0 and second element is 0, such that z plus 0 is equal to 0 plus z, that is added on the right side and added on the left side, that is the right identity, that is the left identity, gives the result z for all z belong to C. Then 0 plus iota 0 is the identity element of complex number under addition, and it is unique. So as identity element exists, so introduction of identity element is responsible or based for the existence of additive inverse. So the fifth property is existence of additive inverse. As 0, 0 is the identity element of Z, then there exists another complex number such that is Z plus Z dash should be equal to 0. That is Z dash is equal to minus Z. So therefore minus Z is the additive inverse because it is under addition, so it is the additive inverse of complex number Z, and it is always unique. So these are the properties under addition of a complex number. Now we will discuss the properties of complex number. Under multiplication, that is same as first property defined in addition. So the first property is the closure property. Same rule as done in addition property. If Z1, Z2 belong to complex number, implies their product belong to complex number, then closure property hold. That is, we can say that multiplication is a binary operation on complex number. So the next property, same as done in the case of addition, that is commutative property. That is, if that is Z1 into Z2, which is equal to Z2 into Z1 for all complex number belongs to complex number system. So, if all Z1, Z2 belongs to complex number system and their product in reverse order is equal to product in actual order comes out to be equal, then we say that commutative property holds. So, the next one is the associative property. In this case, product of Z1 with the product of Z2 and Z3 is equal to product of Z1 into Z2 comes out to be and then taken with Z3. So both these sides are come out to be the same result for all Z1, Z2, Z3 belong to complex number system. Then we say that associative property holds there. So it should be true for all the complex number system. So the next one is, that is a fourth property, that is existence of multiplicative identity. As discussed earlier, identity is that which in the addition property on addition gives the same complex number. So in the same manner in multiplication, it should be multiplied with the complex number to give the original complex number. So there exists a complex number, that is 1, 0 is called multiplicative inverse, such that z into 1, 0 is equal to 1, 0 into z, that is left identity, is equal to z for all z belong to C. And this 1, 0 multiplicative identity is unique. So the next one is, that is the second last, that is existence of multiplicative inverse. To each non-zero. If a complex number is 0, then its multiplicative inverse does not exist. So to each non-zero complex number, z, that is a, b ordered pair, their corresponding complex number a over a square plus b square, comma minus b over a square plus b square, that is denoted by Z inverse, implies that Z into Z inverse is equal to Z inverse into Z is equal to 1, that is 1 comma 0, that is the identity element. So, if Z is equal to A plus iota B, that is ordered pair AB, and Z inverse is A over A square plus B square, comma minus B over A square plus B square, then Z into Z inverse is equal to ordered pair AB into A over A square plus B square, comma minus B over A square plus B square. So by the law of product of these two elements is given as A into C, that is A into C, A square over A square plus B square, minus B into D, minus minus plus, it becomes B square over A square plus B square, comma A into D, that is minus AB over A square plus B square, plus B into C, that is AB over A square plus B square. So we get A square plus B square over A square plus B square, comma minus AB plus AB over A square plus B square. So we get here 1 comma 0, that is identity element under multiplication. So for every non-zero Z belongs to complex number, its multiplicative inverse Z inverse exists and it is unique, as identity element is also unique, and Z inverse is also written as 1 over Z. So the next one is, that is the last property, that is the distributive law. For any 3 complex numbers Z1, Z2, Zc belongs to complex number, then Z1 into Z2 plus Z3 under distributive law will become Z1 into Z2 plus Z1 into Z3, and another law is Z1 plus Z2 into Z3, Z1 into Z3 plus Z2 into Zc. So these properties are the properties of complex number under multiplication, and these properties under addition or multiplication will be used while doing mathematical calculation of complex number.